Hello everyone, today we will solve an equilibrium problem. Here the problem states, in the bridge truss of figure 56, find the forces in members DC, DE, CE, BC, BE and EF. Specify whether each member is in tension or compression. To do this, let's start from joint D, because here only two members are unknown. So we can use only two equations of equilibrium to solve this. For that, let's draw a free body diagram of joint D. FBD of joint D. It would look something like this. Here the leftward horizontal force is DE and the angled upward force is DC, and there's also a 200 ton of force acting upward. Here first we will have to find out the angle between DE and DC. To do that, we will take the help from the measurement of the truss. Here from the measurement we can see that each span is 10 feet and the height of a span is 10 feet. And if we put them in 10 equation, we will get 10 inverse 10 by 10, we will get 45 degree. So the angle between DE and DC is 45 degree. Now let's put the equations of equilibrium. Let's first solve it by summation of f of y, where upward is positive equals 0. Then we can see that the upward force is only 200 ton and the angled DC member. So let's take 200 ton, which is acting upward, so it's positive, plus DC, which is also acting upward, which is also positive, and since it's making an angle with the horizontal axis, so we will take sine 45 degree equals 0. Therefore DC equals minus 200 divided by sine 45 degree. Therefore DC equals minus 200 divided by sine 45 degree. We will get minus 282.84 tons. Since the value we get from it is in negative, so the DC force is acting toward the D joint. So we can say that this force is in compression. Now let's find out the horizontal unknown force, which is DE. For that we will use summation of f of x, where rightward is positive, equals 0. Then we will get, here there's only two forces in horizontal axis, which is DE and the horizontal part of DC, and since both are in the leftward direction, so it will also be in negative DC cos 45 degree equals 0. Therefore we can say DE equals minus DC cos 45 degree. And if we put the values here, then we will get minus, and the value of DC is minus 282.84 cos 45 degree. Therefore, DE equals, since minus and minus are multiplied and we get plus, so we will take only 282.84 into cos 45 degree, then we will get 199.998, so we will take it as 200 tons. Here we can see that the force is acting outward from the joint D, so we can say it's in tension, so we'll mark it as T. Let's move on to the next joint. Here we have two options. We can solve E joint or C joint, and if we focus on the difficulty of each joint, we can see that in the C joint we already know the DC member, so here's only two unknown members, which is BC and CE. On the other hand, for the E joint we have three unknown joints, because here DE is known and EC we don't know it yet, and there BE, that's also unknown, and also EF. So it would be difficult because we are only using the summation of f of x and summation of f of y, or we can say that summation of horizontal forces and summation of vertical forces. So if we use them, we are still missing one equation because there's three unknown, so it would be difficult to calculate. So we will move to the C joint. Here only two forces are unknown, so with these two equations we can solve it. Let's do just that. Here FBD of joint C if we draw the horizontal axis and vertical axis, we can see that if this is the C joint, that we will get BC in this direction, which we don't know it yet, and for the CE, which is acting along the vertical axis, so we will draw it like that, and there's an angle CD similar to the previous angle. It's also 45 degree, because here also the base and the height is 10 feet, and let's mark it here as DC and this as CE. Let's find out the summation of f of y here. Summation of f of y, where upward is positive, equals 0. Therefore we will get CE, which is acting downward, so it's obviously in negative CE, and the angle DC is also acting downward, so we will take it as negative DC, and since it's making an angle with the horizontal axis, then we will take it as sine 45 degree equals 0. Therefore we can say CE equals minus DC sine 45 degree, and if we put the values here, then we will get CE equals minus DC, and if we focus on the value of DC, it was in negative, so in the bracket we will take it as minus 282.84 sine 45 degree. Therefore, CE equals, since we can see that inside the bracket and outside the bracket we have minus, so we will take it as minus and minus multiplied, we get plus. So we will take 282.84 sine 45 degree, we will get 199.998. So we can also call it as 200 turns. And since we can see that it's in the positive, so it's acting outward from the C joint, so it's in tension. And then let's find out the summation of f of x, where rightward is positive equals 0. Here we can see that the DC force is acting along the positive side or the rightward, so we can say that DC, which is angled, and since it has a 45 degree with it, so we can say cos 45 degree, and then minus BC, since the BC force is acting leftward, equals 0. Then we can say BC equals DC cos 45 degree. And if we put the values here, then we will get BC equals DC. The value of DC is minus 282.84 into cos 45 degree. Therefore, BC equals minus 282.84 into cos 45 degree. Then we will get minus 199.998. So we can call it minus 200 tons. And since it's in the negative, so it's acting toward the C joint, so we can call it that BC force is in compression. Let's see here. We already found 4 of the required forces and the nature of it. Now we will have to find out the BE, which is this one, and EF, because we have already found out the rest of them. So if we now focus on the E joint, we will only have 2 unknowns. So it would be similar to the previous joints. We will take FBD of joint E, and let's draw it like this. Let's assume this point as E joint. At the E joint, there is a force acting rightward, which is DE, and there is also a force in the leftward, which is EF, and there's a force at the vertical axis which is pulling it downward, which is 200 tons, and there's also an upward force which is CE, and there's an angled one. Since it's similar to the previous triangles, so we can say that the angle between the horizontal axis and the angled force is 45 degree, and the force's name would be BE. So that's it. Now let's focus on the unknown parts. Here we can see that the BE force and the EF force here are unknown. So let's find out the summation of f of y. for the summation of f of y, we will take upward as positive. Then we will get the CE force which is acting upward. So we will take CE minus 200 tons because it's pulling it downward, and then plus BE because the vertical component of PE is acting upward, and the angle is with the horizontal axis, so we will take sine 45 degree equals 0. Since we are finding out the value of BE, so we will keep the BE at the left side and put all the forces in the right side. Then we will get 200 minus CE divided by sine 45 degree. And if we put the values here, then we will get 200 minus, if we focus on the value of CE, that's also 200 tons, divided by sine 45 degree. And since we can see that the value in the numerator are 200 minus 200, so it would be 0. Therefore BE equals 0. So there is no force acting on the BE member. Now let's focus on the summation of f of x, which we will use to find out the EF force. Here f of x, which is, we will take rightward as positive, equals 0, equals DE, which is acting at the rightward, and there we can see that EF, which is acting leftward, so it's in the negative, and also the horizontal component of BE, so we will take BE cos 45 degree equals 0. Here we are finding out the value of EF, so we will keep the EF in the left side and put all the other forces in the right side. We will get DE minus BE cos 45 degree, and if we put the values here, then we will get DE, which was 200 tons, minus BE, the value of BE was 0, so if we multiply it with cos 45, that would also be 0, so we can say that EF equals 200 tons, and since it's in positive, so we can say that it's in tension. So there we have it, all the forces and its nature. Thanks for watching.